As mentioned in the last lecture, breadboard, also known as prototyping, is a process of testing out an idea by creating a model from which other forms are developed. So, if you are new to electronics, breadboards are often the best place to build, test, and analyze your circuit. The best way to understand how breadboard works is to take it apart and see what's inside. Here we have a breadboard where the adhesive backing layer is removed or peeled off, and you can see a lot of metal strips on the bottom of the breadboard. Now, looking at the top of the breadboard are clips. These clips allow you to stick a wire or the leg of a component through the holes of a breadboard. Here we have a single strip of metal removed from the breadboard. Once a component is inserted to any of these holes, the entire row will be electrically connected. So, on a breadboard, placing a component into any of these holes will get each row connected, and as well this section. If I want to have one row in both sections electrically connected, I can place a jumper wire like this. And here you can see that they are both connected. Then at both ends of the breadboard, any component inserted in any of these holes will get the entire row connected. Most breadboards do have some labels such as numbers, letters, plus and minus sign written on them, while some do not. But the general purpose is always the same. These labels help you locate certain holes on the breadboard so you can follow direction when building your circuit. Some circuits can get complicated, so knowing the row number of a connection you are trying to make will make it much simpler to insert a wire into that number. In this section, we have each column labeled in A to E and F to J. Each row is labeled with numbers. This means that A1 is electrically connected to the holes of B1, C1, D1, and E1. The strip at both ends is typically marked by a red and blue lines. The red with a plus sign and blue or black with a minus sign. These vertical rows are called the power rails or buses. If at some point I need source of power, I can bring in a battery and have them connected to the rails respectively. It is important to note that the power rails on either side are not connected. So, if I want the same power source on both sides, I will need to connect the two sides with some jumper wire like this, keeping track of positive to positive and negative to negative. And here you can see that they are both connected. Many integrated circuits, often referred to as ICs, are manufactured to fit into breadboard, and they come with dual inline package or DPI for short, meaning that they have two parallel rows of pins. So the gap in the middle of the breadboard, known as the ravine, is just the right width for these ICs. If I have a project that uses IC, I will always have it connected this way.